So what we're going to do now is take this table of data and build a graph. And what the graph allows us to see is a pattern. And that's what science is looking for, patterns. That's why graphs are so important to science, because it helps you to see the patterns. Okay?
I have a question.
Yes, ma'am.
How much space are you going to need for this?
I'm going to use a whole sheet of paper, but you might not need it. All right. So let's see. Good gracious. I know it. You guys are popular. Nobody's talking to me. Hello? Okay.
I wish that was me.
Okay. All right. Sure. Well, she's not leaving right now anyway, so it doesn't matter.
Oh.
If you need to. Early dismissal. All right.
How are we going to do it? Yeah, how are we going to do it? We don't have really good numbers.
Well, you can draw an estimate.
And I don't know how do you expect this to be?
Okay.
Okay.
So what we want to do is we want to take this set of data and compare it against this set of data. Okay? What we need to identify is the independent variable. Independent variable is the one that we changed in this experiment. The independent variable is the one that we changed in this experiment. So which data did we change in this experiment?
Diameter.
The diameter is what we changed. We tried different samples of steel wool, didn't we? And the dependent variable is the one that changes because of that. And so we want to compare the independent variable on the x-axis. Independent variables always go on the x-axis. The dependent variable always goes on the vertical or y-axis.
So because we changed it, that makes it what?
What we change is the independent variable, and what changes because of that is the dependent variable. So the time it took it to burn is the dependent variable. Okay? You gotta wake up and sit up. Sit up. Take measures. Let's participating plan. Alright.
You were all the way back there.
Well, I need to do my work too. You copy this down? Maybe somebody next to you has the information. Yeah.
I got the information.
Whatever. I can't hear
I
you.
don't know how many.
Yeah, no, it's not one. Okay, let's take a look. So since this is the one we changed, that needs to go down here on the bottom. We need to label it. Diameter of, let's see, this was a steel wool strand. Okay, and what units of measurement do we use? Millimeters, so we need to say in millimeters. And I'm going from 0.6 up to 0.10. So what I want to do is spread all my data out as wide as I can get it. Okay, so let's say I make this 0.1, and this is 0.09, and this is 0.08, 0.07, 0.06.
Wait a minute, what is that about diameter of what?
Diameter of the steel wool strands in millimeters. What I want to do is spread the data out as best I can. Okay? Which part? This part? Diameter of steel wool strands. Yeah.
I know it's gonna go lunch, right?
Yep. I know you got to do this tomorrow in the lab, don't you? You know your grade depends on it, right? Okay. All right. So I'm going to say, I'm going to start and make this one 0.05 here. And I'm going to skip one and do 0.06.
How many you got on the bottom?
12.
You got 12?
And 0.08, I'm going to skip one, do 0.08, 0.09, and 0.10. Okay, that'll spread out my data pretty well. Does that make sense? Okay, I want to spread out this data as wide as I can on the axis. So I've got to do a little thinking. I've got to kind of figure it out. How can I spread it out? I'm just going to put it on any point. Pay attention here and less amongst each other. Okay? If I were to put each one of these points here, 6, 7, 8, 9, 10 on here, I'd have 6, 7, 8, 9, and 10 here. That'd be bunched up in the corner. Okay? I want to spread all this out the best I can.
You said
Okay, that's
That's what I did. To try and spread it. Okay, that's fine. All right, I want to spread this out too.
Is it on the last one? This is 0.10.
0.10, yeah, matching what's right here. Okay. All right, to spread this out, then I got to figure out, well, how much can I spread these out? I'm going from about 10 to 30. Okay, I want to spread it out. Let's say if I make this 10, and this 11 and 12 and 13, 14, 15, that won't get there.
5.
10, 20, 30. Well, I'd stop right there. They'd be bunching it all up down here in the corner. So I need it wider than that.
5.
So let's make that 10, 15, 20, 25, 30. That's still not spread out as much as I'd like.
That's all you got left.
10, 12, 14. That's being okay. Well, we got to pick the best thing. Let's just make this 10 here, and we'll make this. Let's see, 12, 14, 16, 18, 20. That's not going to do it. So we'll make this one 10. Well, 15, I guess 5s. 16. I'm sorry, 15, 20, 25, 30. That's about the best I can do here.
How many lines you got on that one?
Right here? I don't know. You don't. After this, it doesn't matter anymore.
I use 5.
All right. So looking at this, I've got 0.1 over here matching up against 30. So those two go right there. Okay. Here I've got 0.9 and 0.25, so that goes up about there. Then I got 21.5 and 8. So 21.5 and 8 is about there. 0.7 and 14. 0.7. 14 is about right there. Huh?
How are we supposed to have them straight like this?
You're going to graph it. I'll give you some graph paper to work with tomorrow, okay?
Go back.
Okay. To this?
You know, like, how did you get the first one?
Oh, 0.1 is right here. And 30 is right there. So they match up right there. And the last one goes right here. Now, a best fit curve might mean a straight line, or it might mean an actual smooth curve. But it's not designed to hit the points. It's designed to split the points as best you can. Hit the middle of everything, something like that. See how it doesn't quite hit the points perfectly? That's a best fit line or curve. Now I haven't finished yet because I haven't labeled this axis yet either. I haven't put a title on here. I need a figure label. We'll get to that when you guys have a chance to copy some of this down.
Mine ain't gonna be a straight line.
Well, it's not supposed to be a perfectly straight line. You're going to split it. So notice mine are off a little bit too. That's the idea. You're not supposed to hit the points dead on. You're supposed to have the best line of curve that's smooth, that gets right in the middle of everything. Does that make sense?
No.
We're looking for a pattern. We're looking for a pattern. So this line tells us what the pattern is. It doesn't connect the dots. This is not connect the dots. A best fit line of curve is not connect the dots.
So can you come here with that?
Well, I'm kind of running out of time. I need to get this other stuff here, okay? So give me a minute. All right? All right, we need to label this over here. And what was over here? What are these numbers?
Time.
So time for the sample to burn. And what unit of measurement? Seconds. Okay. We're going to need a title here. Okay, so a title compares the independent variable versus the dependent variable. Okay. So this would be how diameter affects, then it compares it to the dependent variable. Okay, how the steel wool affects, how the diameter of the steel wool affects the speed it burns. Huh? Then we're going to need down here what's called a figure label, like a table label, but this is figure 1. So table labels go on the top, figure labels will go on the bottom. Figure labels will go on the bottom.
You didn't put the table at the top.
I did on the table.
Oh, on top of the table.
Right. Okay, so now listen. Figure labels explain the same kind of stuff, but they go a little bit further. Figure labels explain what's being graphed, why it's important, like the table label, but they also explain what the pattern is. So what kind of pattern do I have here?
Straight line.
Pretty much with a positive slope. Okay, that's called a direct relationship. Okay, so the figure label would describe what's in there, comparison of diameter of the steel wool strands to the time it takes to burn, why it's important. We're trying to figure out the rate at which it burns. The last thing you would tell me about in the figure label is what the pattern is. It shows a direct relationship between the thickness of the steel wool strands and the time it takes to burn. Okay?
We done.
No. But we're done with this. Okay? What are you going to wear tomorrow? Wait a minute, hold it. When do you pack up? Sit down. Yes, there you go. What are we going to be measuring tomorrow?
Water.
Different temperatures.
Okay. What devices are we going to use?
Paper.
Yeah, we'll do some other graduated cylinder.
Water.
Lee, would you get your back out, please?
Oh.
Would you get your ring binder back out, please? Because I asked you not to pack up and I'll tell you to. Thank you. All right. How do you measure liquids in a glass measuring device?
The bottom of the
The bottom of the meniscus. Okay. What kind of measurements should measurements on that kind of device, an analog measuring device, always include that a digital device doesn't include? Well, it doesn't matter what the units measurement are. When you measure on an analog device, you've got to do something you don't have to do with a digital device. No. What do you have to do besides that?
So it's like you gotta look at it from a certain angle.
That's true, but that's not really everything. What I'm saying is I'm trying to get at the fact that you have to estimate one more digit. Okay?
Do what?
Estimate an extra digit. You have to read more than the markings that are on here. You have to estimate between the last two markings. What?
Oh, okay.
I understand that. Okay, thank you. And then when we're done tomorrow, you have to be able to put together a table and a graph. Okay, and I told you how to do that today. So, if you were not paying attention, you were sleeping instead of paying attention, you might not be doing a very good job tomorrow, and your grade will be affected. Okay? So, you might want to get with somebody to figure out how, or come in after school and get some help. You may pack up now. Now listen, I've been very clear about not packing up till I say so. Okay?